Welcome students. Now we are entering to our next problem, that is problem number 6 we are going to work out now. This is also same based on chapter 1 electric fields and charges. No, nothing change in it. So this is another different type of numericals we are going to do in this chapter. So which type of area concept when you see this problem you can able to understand. The particle of mass they given that is placed on a horizontal sheet. When you come to this type of reading the question itself, you have to know which type of area concept we are doing. That should be known very clearly. So first you understand every concept, then you can do the problem very easily. So first we did Coulomb's law, then we go to electric field, then we did electric dipole, and finally we did Gauss law. This is also Gauss law problem. This is applications of Gauss law in our chapter 1 last topic. Because horizontal sheet means you know very well the electric field formula E equal to sigma by 2 epsilon naught. That's only the given. Of charge density. So this is charge density now, definitely we know this is what is that sigma, surface charge density they given. What charge should be given to the particle so that if released it does not fall. Very much clearly they given this problem. Mass given and sigma given. Okay, now they are telling to find out charge Q. Okay, we can find out very easy. First we will do the data. First we have to write the data. Don't be panic after seeing the question. First read the question once or twice and then you will be able to write the data and find out the formula. Then you can do the problem very easy manner. So first what the problem says, okay, everyone will be more curious about this question. A particle, any particle, it contains mass 9 into 10 to the power minus 5 gram. So over a horizontal sheet, that is it is placed in a horizontal charged plane sheet, it is placed here horizontally. Okay, of the charge density they given sigma this value. What charge should be given to the particle, that is Q, so that if released, that means released means it is going to be placed downward. It does not fall, means it should not fall, okay, it does not fall. Then how much of charge if we give, the particle will not fall under the ground. That is the concept they given very clearly, okay. So when means the force will be acting toward downward direction. You know very well about the Newton's second law. So this is normal charge plate, that is positive charge. First I am explaining the concept of this problem. Please listen. Very important problem, repeated code question, this problem. So we have to understand. So this is a normal charged plane sheet. It is placed in the horizontal here. It is placed in the horizontal here. Oh, it contains definitely the two charges. One is positive charge plus sigma and the negative charges minus sigma. You know very well this thing you have to put here. Okay. But it is placed in the horizontal, but definitely it will be exert some forces towards downward direction, because force will be exerted for all the particle, but they're telling very clearly how much amount of charge you will give. If they give that type of charge, the particle should not be released, will fall down on the earth, means ground, it does not fall. So we need to find out charge, but the force will be exerted according to Newton's second law of motion. What the formula of force exerted? F equal to ma, but acceleration acting downward direction, A equal to G. Then how will you put this equation here? F is equal to mg. So that also we have to equate in this problem. So this is a concept which I have given very clearly to this problem. Okay, from which we are going to do here as the data. What are things we are going to write here? Data is, first thing is they given us mass m equal to 9 into 10 to the power of minus 8 gram. You can know, you can ask one question, sir, this is minus 5, we written 10 to the power minus 8. I am just converting into kilogram. So 1 kilogram is 10 to the power minus 3 la. So you just add this 10 to the power 5 into 10 to the power minus 3, it becomes 10 to the power minus 8. Okay, then what they given? Sigma, surface charge density they given. What? 5 into 10 to the power of minus 5 Coulomb meter inverse, Coulomb meter square. Okay, they given mass and sigma. What charge they asking if it is released? So we give only we know m into sigma. What to find out here? Charge. To find is charge. What is the formula for this one? electric field equal to, we know only one formula, E equal to sigma by 2 epsilon naught. This is electric field formula. How we are going to equate this thing into a normal formula? So QE equal to mg, because force is exerting towards downward, so mg. So E value, you know that what is E value, sigma by 2 epsilon naught equal to mg. What we have to find out here? Charge. Then Q equal to what? Cross multiply 2 epsilon naught mg by sigma. So this thing you have to find out. So this is not the concept, I have written as data. So find charge. Formula we know for electric field between the two plate, Gauss Law formula. So this is general formula. This is a given of this charge into mg. This F equal to mg. Here force exerted on the electric field is QE. So QE equal to mg. E we know that. From that we can find out charge Q, cross multiply and divided by sigma. Now we can do solution. Very easy. Solution. Okay. Q equal to 2. What is the epsilon value? 8.854 into 10 to the power of minus 12. Okay. What's the mass they given? 9 into 10 to the power of minus 8 into, what is G? 9.8 divided by, what is sigma? 5 into 10 to the power of minus 5. First see the data which are written very clearly. 2 epsilon value constant, 8.8 by 4 10 to the power minus 12. This is nothing but permittivity in free space air or vacuum, constant value. Then the mass they given, and G value you know, acceleration to gravity is 9.8 constant. Sigma value they given in question. That's just substituted everything as per the given formula. Now if we do this all those calculations, you will get the answer as 3.12 into 10 to the power of minus 13. Charge unit is coulomb. So this is the answer of this problem. Dear students, please work out these values. They are nothing but very easy. Just do the multiplication. I already told in the previous video how to do the calculations. First, multiply the numeric values. So power and all you just take secondary. So remove the powers one side and do the calculation of the mathematical value first and do the power next. After that you will do this all those calculation divided by 5. This 10 to the power minus 5 will go to plus, it will become 10 to the power plus 5 and divided by 5. All those multiplication of numerator and denominator, you will get this answer. Work out and you will get this answer very easily. 3.12 into 10 to the power of minus 13. SI unit of charge is coulomb, see, you know very well. So this is the answer and solution of this problem. So by do mathematically, you will get this answer exactly. There is no doubt in it. And first you got to understand this problem very concept wise. I explained everything very clearly and did this data and the concept to find formula, and we did here as solution. This is solution of the problem. Okay, very, very important problems. This is most and most repeated in our board examination. So please read these questions 1 time, 2 times and understand this concept which I tell you very clearly, and do this work out the mathematical calculation by using normal calculation. Don't use calculator and you will get this answer exactly. Okay, that's all students. So remaining concept will there. This will be see on our upcoming next videos. Thank you students. Thank you.